Let's solve this system using Cramer's rule in the form of determinants. So I write x in the form of top determinant divided by the bottom determinant. And in both the determinants, we will have two columns. In the top determinant, we use this column numbers for the first column. That is, I write 23, negative 8. And for the second column, I use the numbers of the coefficients of y, which is 1, negative 4. This one is basically 1 here. And in the bottom determinant, we use the column of the x coefficients as well as the y coefficients. So first I put these numbers 3 and 2. So here I put 3 and 2. And then I put this coefficients of 1 and negative 4 as a column over here. So here we have two determinants, the top one and the bottom one. Let's evaluate these determinants and do the division and solve for x. And so therefore, let's evaluate the top determinant. So here we have to use the product of this diagonal minus the product of this diagonal. That is 23 times negative 4, and then we put minus product of the other diagonal, which is negative 8 times 1. So this is we have to evaluate for the top determinant. We follow the same thing to evaluate the bottom determinant. So we have to find the product of diagonals minus the product of the other diagonal. So it is 3 times negative 4. We then put minus and then 2 times 1. Let's simplify this. And so this equals 23 times negative 4 is negative 92. And here we have a product of 2 minus, which is plus. So 8 times 1 is 8. And then this is divided by 3 times negative 4 is negative 12. And then we have minus 2 times 1 is negative 2. And so this gives negative 92 plus 8 is negative 84. And this is divided by negative 12, negative 2 is negative 14. So we can cancel these two negatives, and this basically equals 84 by 14, and this equals 6. So we have determined that x equals 6. We now solve for y as like we did for x. So we are going to write y as a fraction of two determinants, that is the top one divided by the bottom one. Let's first put the bottom one using these coefficients, that is x and y. So I put 3, 2, and then 1, negative 4. And in the first column of the top determinant, we put the coefficients of x, that is 3 and 2 as a column. And for the y, or the second column, we put this numbers 23, negative 8. So I put 23, negative 8 here. Let's evaluate these determinants and solve for y. And so therefore we use the product of diagonals and the product of another diagonals. So it is 3 times negative 8. We then put minus 2 times 23 and divided by, let's evaluate the bottom determinants. So this one is 3 times negative 4 minus 2 times 1. And so this equals 3 times negative 8 is negative 24. And minus 2 times 23 is negative 46. And this is divided by negative 2, negative 12, negative 2. And so this equals negative 70 over negative 12, negative 2 is negative 14. We can cancel these negatives. And so it is 70 over 14, which equals 5. And thus we have determined that y equals 5. This is the value of y. So therefore we have determined that the solution set is x equal to 6 and y equal to 5. That is x comma y equals, we can write this as a solution set 6 comma 5.